Okay, so I wanted to do a couple of examples from the new lab manual. This is Fall 2020 lab manual on the ARC average rate of change page on page 40. So example 1, it says determine the average rate of change of f of x equals 2x cubed minus 7x squared plus 15 from x equals -1 to x equals 0. Well, these are x coordinates, so if you want to find the average rate of change, which we know is the formula y2 minus y1 over x2 minus x1, you need to find the y-coordinate partners for these. So I'm going to plug -1 in. So that's 2 times -1 cubed minus 7 times -1 squared plus 15. And then I'm going to plug 0 in. So that's 2 times 0 cubed minus 7 times 0 squared plus 15. And then I'm going to go ahead and use my calculator. So 2 parentheses -1 cubed minus 7 times -1 squared plus 15 is 6. So that gives us the ordered pair -1, 6. And if I put 0 in, 2 times 0 cubed minus 7 times 0 squared plus 15 should give us 15. So our ordered pair 0, 15. So if you're given a function in x values, inputs, you should be able to find the outputs. Now we'll plug it into the ARC formula. Let's let that be x1 and that be y1, and this be x2 and that be y2. So that would be 15 minus 6, y2 minus y1, over 0 minus a -1. That minus is part of the formula. That negative belongs to that number. So 0 minus a -1 is +1. So 15 minus 6 is 9 over 1, which is just 9. So that's your average rate of change between -1 and 0. Okay, it doesn't even matter what type of function you have. This is an exponential function minus x squared. So we've got inputs and we have a calculator, so we'll find f of 3. So that's 2 cubed minus 3 squared. Don't need a calculator for that. That's 8 minus 9. That's -1. So we have the ordered pair 3, -1. F of 5, that's 2 to the 5th power minus 5 squared. 2 to the 5th is 32 minus 25. That's 7. So we have the ordered pair 5, 7. So plug it into the formula, average rate of change formula. y2, which is 7 minus -1, which is y1, over x2, 5 minus 3. So 7 minus the -1 is 8. 5 minus 3 is 2. Make sure we reduce. That reduces to 4. So if we wanted to do number 3, where you have variables, the concept isn't going to change. The algebra will get harder. So we're given inputs and we want to find the average rate of change. Well, we need the outputs. Well, to find the outputs, you put the inputs in. So if I put a in, I get 2a minus 3 and you're done. That's all you can do. So the ordered pair is a to a minus 3. If I put a plus h in there, that's 2 parentheses a plus h minus 3. That's distribute, get a plus 2h minus 3, and you're done. There's no like term. So that's the ordered pair a plus h to a plus 2h minus 3. So now average rate of change isn't going to change. It's just now we've got to put in variables, but our x1 is a, our y1 is 2a minus 3, our x2 is a plus h, our y2 is 2a plus 2h minus 3. So we just plug that in. So y2 minus parentheses, because that's tricky. There's two terms in that one y coordinate, so you've got to use your parentheses because people forget to distribute that negative if they don't. Over x2, x2 is a plus h, minus x1, which is a. these a's cancel. A minus a is gone. So what we have here is 2a plus 2h minus 3 minus 2a plus 3. That's the spot right there where people mess up. They forget to distribute that negative over h. So this 2a and this minus 2a cancel to 0. This negative 3 and this 3 cancel to 0, and you're left with 2h divided by h, and you get 2. Then the question is, what value does this number 2 compare to in the original function? Well, what's the original function? And you see a 2 here, and that's the slope. And this is a function of a nice straight line with a y-intercept of negative 3 and a slope of 2. So the reason that this is 2 is because no matter what values you put in for your inputs, no matter what, your slope is going to stay a constant rate of change of 2. That's the slope of a straight line. This one is going to have a different average rate of change depending on what two inputs you pick.